Question 2. This question is about enthalpy changes. Write an equation including state symbols. So you have to put S for solid, G for gas, L for liquid, AQ for aqueous or dissolved in water. To show that the reaction takes place when the standard enthalpy of combustion for ethanol is measured. So you have to put ethanol, it's a liquid, plus oxygen, O2, which is a gas, and then CO2, which is a gas, and H2O, which will be a liquid. And then you've got to balance it. So combustion, a reaction with oxygen, and if it's complete combustion, as we'll assume it is, then it makes carbon dioxide and water. State the name given to the enthalpy change represented by the following chemical equation. That's the formation of carbon monoxide from its elements, carbon and oxygen, in their standard states, how you'd find them in the laboratory under normal conditions of temperature and pressure. In other words, carbon is a solid and oxygen is normally found as a gas. So enthalpy of formation, to form carbon monoxide, and 1 mole of carbon monoxide, by the way. Explain why this enthalpy change would be difficult to determine directly, because there's a chance that the carbon monoxide would react with further oxygen and make carbon dioxide. Standard enthalpies of combustion for carbon and carbon monoxide are -393 and -283 respectively. So for carbon it's -393 and carbon monoxide -283. Use this data to calculate the enthalpy change for the reaction in 2.2 here. So the enthalpy change is the sum of the enthalpy of combustion of reactants, take away the sum of enthalpy of combustion of the products. So you have reactants take away products, and since we're talking about combustion, it's the sum of the enthalpy of combustion of the reactants and the sum of the enthalpy of combustion of the products. Now, for carbon, so enthalpy of combustion of carbon here on the left, it's -393, and enthalpy of combustion of carbon monoxide here on the right, it's -282. So it's take away, subtract a minus. So -393 minus or plus 283 comes out as 110 kilojoules per mole. Use the following data to calculate a value for the xenon to fluorine bond in xenon F4, XeF4, and you've been given two equations. You need to form a Hess's law, so Hess's law cycle needs to be drawn, and if you have a look here, xenon gas plus 2F2 to xenon tetrafluoride is -252 in this direction here, going from left to right. And fluorine gas going to fluorine atoms, the enthalpy of atomization from fluorine F2 here to F gas is +158. Now we're breaking up xenon F4 into its atoms Xe and F4Fs here. So it was breaking it up into Xe and 4Fs. Then Xe going to Xe is nothing, so that one is nothing because it's already as it is. So I could break XeF4 up into Xe and 4Fs. I know I've only got two, I'll come to that in a minute, and that's the enthalpy that we're looking for, the enthalpy of the bond enthalpy. So the energy to break a bond, or those 4 bonds rather. So the 4 bonds, so I'll have to divide by 4 to get one of them. So if I started off with here and went down to here, the other way of doing it is here to here, so it would be plus 252. This one to here is 0, so I can forget about that. 2F2 to 4Fs, well I've got F2 to 2Fs is plus 158, so I can double that. So now I've worked out this change here, plus 252, 0 for this one, 158 multiplied by 2, 568 to turn this XeF4 into Xe and 4Fs. I want the bond enthalpy of one of them, however, so I'm going to have to divide by 4 plus 142. Now bond enthalpy to break a bond, the energy to break a bond, is going to be endothermic. It's going to require heat take in heat. Suggests a reason why the value in 0.2 differs from the mean XeF4 bond enthalpy quoted in a data source. It's because the mean bond enthalpy is found by taking an average of this in a range of compounds. So it might be Xe to F bond with other atoms bonded around it in another compound. In other words, the Xe to F bond changes depending on what else is bonded to it. So in this case, Xe to F has got 3 other Xe to F bonds around it, but it may not have. So we find the Xe to F bond from a range of compounds and take a mean. So in this case, it might be slightly different than the mean value when we've taken the average of the Xe to F bond enthalpy in other compounds into account as well.